This is the second video for September 7th or September 8th, and what we're looking at is how multiplying x by a number changes our parent function, specifically how it changes the period of the function. And we ended up here, is that if we're multiplying x by a value, whatever value that is, we would take, for sine and cosine, we would take the parent function period, which is 2 pi, and divide by that value. So what we talked about here in most class, I think there's only one class we didn't do this in, is let's talk about what's happening here. Here we have sine of 1/2 x minus pi over 2. And what I told students is, or asked students to do, is hypothesize. What do you actually think will happen to this function? If you want to pause and write that down here, that might be a good thing. But let's think about what's actually happening, what we think will change to the function. Again, if you want to pause it and hypothesize on your own here, that might be a good thing. But after having some time to talk about it with their partner and discuss about it, what students said is, well, hey, x is being multiplied by a number here. Because x is being multiplied by a number, I know that the period is going to change. So we start with 2 pi because that's the parent function period of sine. And then since x is being multiplied by 1/2, we would divide by 1/2, which is the exact same thing as multiplying by the reciprocal. If I take the reciprocal of 1/2, we get 2. So our period is 4 pi. Students also said, because we're subtracting pi over 2 inside our function, what's going to happen is we're going to shift the entire function to the right pi over 2 units. But after students had time to talk about this and explain what their reasoning in terms of the values that are inside the parentheses of what they're telling us, what we actually noticed is this function, the period is 4 pi. That is true. But when we subtracted the pi over 2 inside as well, what happened is this function shifted to the right, but it didn't shift to the right pi over 2, it actually shifted to the right pi units. It seems like, where the heck is this coming from? And what's happening here, and this is a small piece, it won't be assessed too much. I might have 1 or 2 problems on the assessment that make you do this. But what's happening here is anytime x is being multiplied by a value and added or subtracted inside of the function, we have to get x alone to actually figure out the transformation. And what I mean by that is we actually have to move this 1/2 and put it away from the x. We need to factor that out. Now, if I factor out this 1/2 x, what we're really doing here, so for example, if we have 2x minus 8y, the 2 factors out, and we're left with x minus 4y. And I asked students, well, why is it just x? Why did the 8 become 4? And what a lot of students said is, if I factor out a 2, then what we need to do is take 2x divide by 2 to get x, 8y divide by 2 to get the 4y. And that's exactly what's happening here. We just have to factor out a fraction. So if I have 1/2 x, I factor out 1/2. Really what's happening is 1/2 x divided by 1/2, a number divided by itself, will just leave us with x. But then we have to take pi over 2 and divide it by 1/2 as well, because we're factoring it out. And once we do that, we could take pi over 2, we're dividing by 1/2 or multiplying by the reciprocal. Pi times 2 is 2 pi, 2 times 1 is 2. And so what we get is 1/2 x minus pi. And so because once we factor out the 1/2 here, then that's causing the shift to the right pi units. So that is a wrinkle if we're multiplying x by a number and adding or subtracting inside of the function, then we do need to factor out that number. If we factor out that number away from x, then we're left with just x here. But whatever we factor out, we also have to divide this second term by that number. A lot of times it'll be a fraction. We can multiply by the reciprocal and simplify to figure out the actual shift to the right. And some students were like, well, what is this 1/2 doing? Well, it's still tied here. That's still affecting our period. So every number is telling us something. We just need to take a look, pause, and think about what is every number telling me about our function, and that's going to be key to graphing these functions. We did not get to this at all. If you want the practice, please, by all means, try it, ask me questions about it. This is where we ended in a lot of classes, and then the next class, we are actually going to spend a lot of time practicing how to graph these, what it looks like, all those different transformations. If you have questions at all on what's happening here, please ask me. Through Remind, email, website, before school, after school, please ask me. Love to answer the questions. The biggest takeaway, though, is whatever x is being multiplied here is being multiplied by 1/2. The big takeaway from the day was take 2 pi, because that's our parent function period, divide by that number, and that's going to give us our new period.